Okay, so we can get started with the first one. All right, if it says to solve each equation, you can solve it however you want to solve it. All right, how would we start this one? We need the entire equation set equal to what?
0.
To 0, good. So we want to subtract that 3 from both sides. Whoa. All right, and then we get this equation equals 0. And then we're left with 2x squared plus 9x plus 4 equals 0. All right, how would you solve it from here? Now you can either factor or use the quadratic formula, right? I would always check if you can factor, right? So how would we factor something like this? All right, we're checking what multiplies to 2 times 4, so 8, and what adds to the middle term 9, right? Which two factors? Should be 8 and 1, all right, good. All right, now from here you can split up the middle term. So we get 2x squared plus 8x plus x plus 4 equals 0. And you factor by grouping. All right, so you want to group the first two and group the second two. All right, now GCF of the first pair is going to be a 2x, and you're left with an x plus 4. And GCF of the second pair, you don't see one, so you can take out a 1. And you still get that x plus 4 on the inside. All right, we're following so far? All right, so now we want to finish factoring this. We want to get 2x plus 1, right? Those are the GCFs that we just took out, times x plus 4 equals 0. And then from here, we set each factor equal to 0. So we get 2x plus 1 equals 0, x plus 4 equals 0. And then you solve each of these. All right, so for this one, we want to subtract 1 on both sides. We get 2x equals negative 1. Divide both sides by 2. We get x equals negative 1/2 as one of our answers. And then for our other answer, we subtract 4 on both sides. So you get x equals negative 4. Now, if you didn't want to factor it and you did quadratic formula, right, that's fine, but I saw a lot of students today that use the quadratic formula, maybe got to an answer that looks something like this, right, and just left it like that. If you use the quadratic formula and you get this, you need to split it up and get two answers. Right, because negative 9 plus or minus 7 over 4 is not fully simplified. We should get negative 1/2 and negative 4. All right, let's keep going. Let's try number 3. Again, with any of these problems, we want the entire equation set equal to what?
0.
To 0, good. So we can subtract 6 from both sides. We get 2x squared minus 3x minus 5 equals 0. All right, let's try factoring this. All right, how are we going to factor something like this? Okay, good. So what multiplies to 2 times negative 5? So negative 10. And what adds to negative 3? All right, can we think of two numbers? Negative 5 and positive 2. Right? We agree? All right, so we split up the middle term using these two numbers, right? And we're doing this because there's a number in front of the x, right? If there's a number in front of the x squared, sorry. If there's a number in front of the x squared, you always want to split it up and factor it by grouping. All right, so we should get 2x squared minus 5x plus 2x minus 5 equals 0. All right, and now you want to group the first two and the second two. All right, GCF of the first pair, you can take out an x, and you're left with 2x minus 5. And then in our second group, you can take out a 1. Right, if there's nothing that you can take out, just take out a 1. All right, and now the insides of your parentheses match. So we should get 2x minus 5 times x plus 1 equals 0. All right, so far so good? All right, what do we do from here? Very good, set them both equal to 0. 2x minus 5 equals 0, and we get x plus 1 equals 0. All right, let me write those up here. All right, for 2x minus 5 equals 0, we want to add the 5. And we get 2x equals 5, and then divide by 2. So you get x equals 5 over 2 as one of your answers. And then for the other one, you just want to subtract 1. So you get x equals negative 1. All right, same thing with this one. If it just says to solve, you can use the quadratic formula if that's what you want. But you're going to have to fully simplify your answer at the end. All right, but either way works. All right, questions on any of that? Good. All right, how are we going to do number 5? Okay, so you could FOIL it, right? But this one's set up already to where you can do it much simpler. Right, what can we do to both sides right away? Square root, right? Very good. You have a squared term or expression by itself. So you can square root both sides and cancel out the square. So we get x minus 3 equals square root of 7? Plus or minus, right? Good. Positive and negative. Square root of 7. All right, and the last thing you want to do is add the 3 on both sides. So we get x equals 3 plus or minus the square root of 7. And can we do anything else with that? No? Okay, right. Square root of 7 can't simplify. You can't add a whole number in a radical. So this would be your final answer. You would get the same thing if you FOILed it and used quadratic formula. You could quadratic formula your way through the entire test, but that's not going to be the fastest way to do it. If you do that, you're going to run out of time. Right? Notice that there's not a lot of work here. All right, questions on that one? Okay, so now let's try this next one. Let's try number 7. This one says to solve by completing the square. Right, now let's say it didn't say that. Let's say it just said to solve. What should be the first thing that you look for? To see if this expression can what? Okay, good. You want to check if you can factor. If it just has to solve, You should always check if you can factor it, right? Can you factor this this equation? Is there anything that multiplies to -6 and adds to -2? No, right? So this one says to solve by completing the square, so let's do it that way. All right, do you remember how to complete the square? Not at all. Let's first start by getting the constants to the other side. Good luck. So let's add 6 to both sides, right? That was our first step, is to get an x squared minus 2x, and we have a little space, equals 6, and again, plus a little space, or a box, however you remember it. Right, and what goes in that box? Something divided by 2. Okay, that something is this one right here, right? B. B over 2 squared. Right, so we're doing b over 2 squared. And if b is -2, we have -2 divided by 2, which is -1. And when you square -1, what does that become? It's just 1, right? Good, right? So in this box, you're going to put a positive 1. Now, why did we do that? What was the point of doing that? So we can do what to this side of the equation? Okay, so this is going to become x minus 1 squared. This minus 1 comes from, bless you, from this -1 right here, right? It just comes from b over 2. So this entire expression, our third step was to do x plus b over 2 squared, right? And this is so that we can get it to be a perfect square. Right, and then on the other side, you just want to add 6 plus 1. It's going to get you 7. Right, and now this is the easy step. Right, what can we do from here? Good, square root both sides. So then you get x minus 1 equals square root of 7? Plus or minus, good. Right, plus or minus square root of 7. And then the last thing you want to do is you want to add the 1 on both sides. So we get x equals 1 plus or minus the square root of 7. Can we do anything else to that? All right, no. So we can leave this alone. All right, so x is equal to 1 plus or minus the square root of 7. Again, this one just said to solve by completing the square. Right? If it didn't say that, solve it however you wanted. I know a lot of you like quadratic formula, right? That would have worked here, but again, like I keep saying, you want to make sure that if you use quadratic formula, simplify your answer fully. Okay, so let's look at number 9. This one says to solve using the quadratic formula. Do we remember the quadratic formula? All right, so help me out. It's going to be x equals, okay. Okay. All over 2a. Nice, good. All right, so you need to remember this. You need to commit it to memory. All right. But again, if it didn't say that, if it just said to solve, what do you want to check that you can do to this equation? You want to check if you can factor it, right? Is there anything that multiplies to -9 and adds to 3? All right, no, right? So your only options here, let's say it just said to solve, would be completing the square, quadratic formula. All right, this one says quadratic formula, so let's do it that way. Let's label A, B, and C. Right, so what's A, what's B, and what's C? Okay, B is 3, and then C would be -9, right, your constant. Once you have these numbers, and if you have your quadratic formula memorized, then all you have to do now is just plug in your numbers. So you get x equals -3 plus or minus the square root of 3 squared minus 4 times 1 times -9 all over 2 times 1. All right, now let's evaluate this. It's going to get us -3 plus or minus the square root of 3 squared is 9. -4 times 1 times -9 is going to get you a plus 36. All right, careful with your signs. And then over 2 times 1 is just 2. All right, now let's simplify this. 9 plus 36 is going to get you 45. So we get x equals -3 plus or minus the square root of 45 over 2. You guys agree? All right, are we done? All right, what do we have to do now? Okay, let's simplify the square root of 45. Okay, very good. Does it have any factors that are perfect squares? Okay, good, right? So we can do square root of 9, square root of 5. All right, and square root of 9 gets you 3. So we get as your answer x equals -3 plus or minus 3 square root of 5 over 2. And you cannot simplify this any further, so this is fine as is. Now let's just say for some reason, instead of a 2, you ended up with a 3 in the bottom. Right, let's just say you ended up with a 3. In this case, you're able to cancel out a common factor from the top and on the bottom. Right, so you're going to want to do that every time you see that there's a perfect, or that there's a factor on the top, on the bottom, a common factor, you can cross it out. If you're ever unsure, you can always just split it up every single time and check if it simplifies. Right, if you had a 3, then this would simplify to -1 plus minus the square root of 5. Right, so you need to make sure it's fully simplified. Let's say you didn't catch it and you just want to make sure every time that it doesn't simplify any further. You can always split it up every time. So in this case, let me erase this. Oh, hang on. Right, so in this case, we had -3 over 2 plus or minus 3 square root of 5 over 2. And then you can see that neither of them simplify, so you can leave it alone, right? This is equally acceptable. All right, let me zoom out. Any questions on this one? All right, let's keep going. Now again, this one just says to solve. Right, so what should you check if this equation does? Factor, right? Always check if it factors if it just says to solve. And in this case, to factor, you would need a 3 times 5 to get 15. Right. That factors of 15 that add to -2, are there any? All right, there are not, so you cannot factor this one. Right, so you can do either completing the square or quadratic formula. All right, now I'm not a big fan of completing the square, and especially not in this case, right? Can you guys see why? Right, it doesn't go evenly. If there's a number in front of your x squared, you would need to divide everything by that number. And then you would end up with fractions, and then when you do b over 2, you get even more fractions, right? And you guys don't like fractions, right? Nothing wrong with that. Let's just get rid of that, right? Let's use quadratic formula here. Now again, you need to know the quadratic formula. All right, so let's label a, b, and c. A is the number in front of your x squared, so a equals 3. B is in front of your x, so -2, and C is your constant, so 5. All right, now you guys give this one a try, right? So try plugging this into your quadratic formula and let me know what you get. Okay, so let's give this one a try. So when you plug into the quadratic formula, we should get x equals -2 is going to get you a +2, right? So 2 plus or minus the square root of -2 squared minus 4 times 3 times 5 all over 2 times 3. All right, so we get x equals 2 plus or minus 2 squared is going to get you 4. Right, and 4 times 3 is 12, times 5 is 60, so we get the square root of 4 minus 60 over 2 times 3 is 6. All right, so we get x equals 2 plus or minus the square root of -56 over 6. All right, don't make a mistake with the sign here. Right, it should be a -56. All right, but we have an issue here. What do you do with that negative under the radical? Okay, good, right? You want to take out an I, right? This section is also covered on the test, right? So don't forget, I's are possible, right, in these problems. We get I square root of 56. All right, now let's simplify the square root of 56. Are there any perfect squares that are factors? Why don't we try 4? All right, can you multiply 4 by anything to get 56? 14. Good. All right, and the square root of 4 is going to get you 2. So we get x equals 2 plus or minus 2i square root of 14 over 6. All right, don't forget the I. And now you just want to make sure that you fully simplify, right? So at this point, you can split your answer up into 2 parts, a real and an imaginary. So we get 2 over 6, plus or minus, right? Plus or minus 2i square root of 14 over 6. And then simplifying each of these fractions, 2 over 6 becomes 1/3. And then 2i square root of 14 over 6, you can simplify 2 and 6. We get a 1i square root of 14 over 3, or just I square root of 14 over 3. All right, now I'll leave this entire thing up. All right, I'll keep going. I'll leave this on the screen, but I'll do the one right underneath it, right? So number 13, right? If this just says to simplify, and you see 2 complex numbers being added, right? How do we simplify something like this? 7 plus 3i plus 5 minus 4i. All right, we wouldn't do that. We see a plus in between them. Right, so it's simpler than that, actually.
You just had to realize.
Okay, good. So you do real plus real, imaginary plus the imaginary. Right, so 7 plus 5 is 12. 3i minus 4i is what? Minus, good, yeah, or you can say minus I. Right, that's all you need to do here. Right, you don't need to make these any more complicated than they are. If there's a plus in between, you're just combining like terms, right? So real plus the real, imaginary with the imaginary. Okay. Questions on that one? Okay, let's try 15 now. So again, it's going to be the same thing. We have three complex numbers here, right? One is a plus and one is a minus. Right, so I'll just go from left to right. Let's just do one of them first, right? So let's do 5 plus 3. Let's do the real plus the real. Is going to get us an 8. Minus 3i plus 5i is going to get us a plus 2i. All right, minus 8 plus 2i, right? And maybe you see what happens already. Right, this minus is going to change the sign of everything on the inside, so we get 8 plus 2i. Minus 8 minus 2i. And 8 minus 8 goes away. 2i minus 2i also goes away. This whole thing is equal to 0. All right, let's keep going. Let's try number 17 now. All right, how are we going to simplify something like number 17? Yeah, good, right? Okay, nice work. So, yeah, for these, you do want to FOIL, right? These you're multiplying, right? So you want to do 2 times 3, 2 times 3i. Negative 4i times 3 is going to get us negative 12i. And negative 4i times 3i is going to get us a negative 12i squared. Anytime you see an I squared, you want to do what? Change the sign. Good. Cross it out. Change the sign in front of it. All right, so now let's combine. Real plus the real is 6 plus 12 is 18. 6i minus 12i is negative 6i. All right, so you get 18 minus 6i. All right, let's keep going. All right, now number 19. Right, this is a division problem. Right, how do we simplify something like this? Right, remember we don't want i's in the denominator. So how do we get it out? All right, you want to multiply the top and the bottom by what? Okay, good, right? The complex conjugate, let's multiply. What's the complex conjugate of 4 minus 2i?
4 plus 2.
Very good. All right, so let's do 4 plus 2i. All right. And then what's the bottom going to become? All right, remember, there's a shortcut for this.
We have to do 4 times 4, like 4 to the second power.
Okay, yeah, good, right? So we square our real number, which is 4, so 4 squared, plus square the real part of your imaginary. So 2 squared, right? 4 squared plus 2 squared. You could FOIL it out. If you don't understand the shortcut, then maybe you shouldn't use it, right? If you don't understand the shortcut, you can always FOIL it out and you should get the same thing. Right, so again, on the bottom, we're squaring the real, plus we're going to square the real part of the imaginary. So 4 squared plus 2 squared. And then on the top, we just want to FOIL. So we get 2 times 4, which is 8. 2 times 2i is 4i. 3i times 4, 12i. And 3i plus, or times 2i is plus 6i squared. Again, anytime you see an I squared, you do what?
You change the sign.
Okay, good. Cross it out, change the sign in front. It becomes minus 6, right? Real number 6. All right, and 8 minus 6 on top, right? So on top, let's combine everything. It's going to be real plus the real, so 8 minus 6 is going to get you 2. Imaginary plus the imaginary, 4i plus 12i, which is going to get us 16i. All right, over 4 squared is 16, plus 2 squared is 4, so 16 plus 4 is 20. All right, I didn't write it in the directions, but this should be in standard form. All right, what's standard form of a complex number? All right, standard form of a complex number is a plus bi, right? Your real plus your imaginary. And to get that, we just split up the fraction. So we get 2 over 20 plus 16I over 20. All right, and 2 over 20 is going to get you 1 over 10. 16I over 20, greatest common factor there is going to be 4. All right, so we get 4I over 5. All right, divide them both by 4, and this should be your final answer. All right, now let's try number 21. All right, same idea here. We don't want i's in the denominator. Right, so how do we simplify this? We multiply the top and the bottom by what? Okay, good. Conjugate of 1 minus I is what? 1 plus I, good. So let's multiply 1 plus I on the top and on the bottom. All right, and on the bottom, to simplify, we can use the shortcut. It's going to be 1 squared plus, if there's nothing in front of the I, you assume it's 1. So 1 squared plus 1 squared, which is just 1 plus 1, so this is just going to be 2. All right, so we just get 2 in the bottom. And on the top, we can distribute 13. 13 times 1 is 13. 13 times I is 13I. All right, last thing you want to do is simplify and write in standard form. Right, 13 and 2 can't simplify, so we're just going to split it up and leave it alone. Right, 13 over 2 plus 13I over 2 is your simplified answer in standard form. All right, any questions on that one?
For that one, you have to split it.
Yeah, if it says to write in standard form, then you still need it in a real plus imaginary, right? Even if it doesn't simplify. Right, I believe for the complex numbers, we'll give you multiple choice. Right, so if that's the case, you just find your answer. If you get this far, then you should at least see your answer. All right, written in standard form. All right, let's do a couple more. Okay, let's try 23. All right, to simplify something like this, we first want to take out what? Okay, good. Let's take out the negative. Let's turn it into I. We get I square root of 160, and we can split 160 into which factors? All right, 16 and 10, maybe? All right, we can try these. If you didn't recognize these, you can use the factor tree, right, and simplify until you can't anymore, right? But this would be the biggest perfect square that you get, right? Square root of 16 is going to get you 4, and the square root of 10 you can't simplify, right? So this answer is just going to become 4I square root of 10. All right, and I'll do one more with you guys. All right, so let's try 25. All right, looks a little bit different, but still, it's going to be the same thing. We just want to simplify, right? We can take out the negative from the top and on the bottom, so we get I square root of 90 over I square root of 10. All right, and then I divided by I, that goes away. And then square root of 90 over square root of 10, since they're both under a radical, you can write them both under the same radical. Right, so this is the same as 90 divided by 10, which is just 9. And then square root of 9 just gets you 3. All right, so this should cover everything that you can expect to see. All right, so it's going to be solving equations, every method, right? And then you want to simplify any radical expressions with i's.